10 tons of TNT went off 28 miles above the Columbia Basin early on Friday morning, and nobody on Earth knew it was coming. The object was about 16 inches across, moving at 32,800 miles per hour. 5 volcano monitoring stations in the Cascades recorded the pressure wave. NASA has ruled out the Perseids. What it has not explained is where this thing came from, and the answer points straight into the one part of the sky nobody has been able to account for all year. At 12:48 in the morning, Pacific Daylight Time on Friday, August 14th, a piece of an asteroid entered the atmosphere over central Washington state and detonated. The energy released when it came apart was roughly equivalent to 10 tons of TNT. It was over in about 4 seconds. People saw it from 4 separate jurisdictions: Washington, Oregon, Idaho, and the Canadian province of British Columbia. It was bright enough that residents across the Columbia Basin and the Spokane area woke up, checked their doorbell cameras, and found the flash already recorded. One resident in Spokane Valley told a reporter he assumed something had happened at a neighbor's house. It took him a moment to work out that the light had come from the sky. That is the ordinary version of this story, and on its own it would be a footnote. What makes it worth your time is everything underneath it. This object was recorded in unusual detail by instruments that were never built to record anything of the kind. And the reconstruction those instruments produced contains a number that does not work, a direction nobody has explained, and a blunt admission from the people whose job it is to watch for this. They had no idea it was coming, and there is currently no way they could have. The American Meteor Society's Fireball program monitor, a man named Robert Lunsford, put it plainly. Fireballs, he said, are always a surprise. They have to be extremely large to be visible before they enter the atmosphere. This one was not large. According to NASA, it was about 16 inches across. The reconstruction NASA published is unusually specific for a fireball, and everything that follows rests on it. The object first became luminous at an altitude of 77.9 kilometers and went down 48.4 miles up, directly above the town of Soap Lake, Washington. It was traveling at 14.6 kilometers per second, which NASA rendered for the public as 32,800 miles per hour. It moved north. It traveled roughly 36 miles through the upper atmosphere before it came apart at an altitude of 45.5 kilometers, 28.3 miles, above a place in Douglas County called Sims Corner. The object itself was approximately 16 inches in diameter, weighing approximately 170 pounds, a rock roughly the size of a beach ball. So how do you measure the flight path of a beach ball traveling at 33,000 miles per hour in the dark? NASA drew on 3 separate data streams, and only one of them was designed for the job. The first was eyewitness accounts filed with the American Meteor Society. Nearly 250 reports had come in by Friday from Washington, the Columbia River Corridor, Northern Oregon, Idaho, and British Columbia. Figures circulating later that day had risen to 266. The second was 3 publicly accessible cameras, not a dedicated fireball network. 3 cameras that happened to be pointed at the sky and happened to be reachable. The third is the interesting one. The geostationary lightning mappers aboard the GO-ES weather satellites detected it. Those instruments exist to map lightning. They watch for optical flashes at a specific wavelength, the 777.4 nanometer atomic oxygen line, and a rock exploding in the upper atmosphere produces exactly that kind of flash. Regular viewers will remember the daylight fireball that broke up over New England back in May, caught the same way. A weather satellite's lightning detector is currently one of the most reliable tools North America has for catching these things, and nobody designed it to do that. That is a pattern, and it repeats. The most unusual observational detail of this entire event has nothing to do with space. When the object fragmented at 28 miles up, it produced a pressure wave, and that wave was recorded on United States Geological Survey infrasound instruments installed at 5 Cascade volcanoes: Glacier Peak, Mount Rainier, Mount Adams, Mount St. Helens, and Mount Hood. Signals arrived at those 5 stations between 12:55 and 1:10 in the morning Pacific time. The flash was at 12:48, so the arrivals came in between roughly 7 and 22 minutes after the object exploded. That delay is not mysterious, and it tells you the wave was real rather than an instrument artifact. Infrasound is sound. It travels at roughly 0.34 kilometers per second near the surface, so the spread of arrival times is a direct function of how far each station sits from the explosion, between about 140 and 440 kilometers. The numbers line up. But look again at what those instruments are. They are volcano monitors, bolted to the flanks of Cascade volcanoes to listen for eruptions, rockfalls, lahars, and gas jets. They exist because Mount St. Helens killed 57 people in 1980, and the agencies responsible decided they would rather hear the next one coming. On Friday morning, they heard a rock from space instead. The Cascades Volcano Observatory issued its routine weekly update at 6 minutes past 11 that same morning, confirming every Cascade Range volcano in Oregon and Washington remained at normal background levels. In the space of a few hours, that observatory had to look at an unusual pressure signal on 5 of its own stations, determine it was not volcanic, and say so publicly. They did. This matters beyond the anecdote, because there is no dedicated national bolide infrasound network in the United States. What exists instead is a patchwork. The international network built to detect nuclear tests, a handful of research arrays, and volcano stations like these. This event was recorded well because it happened to explode inside a volcano observatory's listening range. An identical object over the Great Plains would have been heard by far fewer. We measured this one by luck. Hold on to that because it comes back. The speed is doing more work in this story than any other single number. 14.6 kilometers per second sounds enormous, and in human terms it is. But in the context of things that hit Earth's atmosphere, it is slow. The Perseid meteor shower, still highly active that night, having peaked Wednesday into Thursday, delivers particles at about 59 kilometers per second. This object was moving at roughly a quarter of that. NASA was explicit about the Perseid question, and the phrasing left no room. This fireball was not part of the Perseid meteor shower. It was a background sporadic meteor. A sporadic is exactly what it sounds like. Not part of a shower, not associated with a known comet, not on anybody's calendar. A rock that was simply out there on its own orbit until Earth ran into it. An entry speed that low tells you something specific about that orbit. It means the object was traveling on a path around the Sun, very close to Earth's own. Low eccentricity, low inclination, an orbital size near 1 astronomical unit. It was going the same way we are, in roughly the same plane, and Earth caught up to it rather than slamming into it head-on. That is a fundamentally different object from a fast cometary particle on a backward orbit. One discrepancy in the public record is worth flagging. Lunsford, speaking to a local paper before the formal solution was released, estimated the speed at about 25 miles per second. NASA's solution came in at 14.6 kilometers per second, a factor of nearly 3 lower. Eyewitness-derived speed impressions routinely run high, and a trajectory solution built from satellite data, camera footage, and witness triangulation supersedes a same-day field estimate. Here's where it gets strange, and the honest reading is much less exciting than the one circulating online, and still worth your attention. Take NASA's own published figures and do the arithmetic. 170 pounds is 77.1 kilograms. An object of that mass traveling at 14,600 meters per second carries a kinetic energy of 1/2 times the mass times the velocity squared. That comes to 8.22 billion joules. 1 ton of TNT equivalent is 4.184 billion joules. So the entire kinetic energy of a 170-pound rock at that speed, every last bit of it, converted perfectly with nothing left over, is approximately 1.96 tons of TNT. NASA's published fragmentation energy for this event is 10 tons of TNT. Those two numbers differ by a factor of roughly 5, in the direction hardest to explain. The energy the agency says was released is 5 times larger than the total energy the object it describes could possibly have carried. Run it backwards, and it gets no better. An airburst of 10 tons at that speed requires a mass of about 392 kilograms, 865 pounds, more than 5 times the published figure. Now, the mundane explanation, which is almost certainly the right one, bolide masses are not measured, they are back-solved. What the satellite's record is optical energy, how much light came out. That is converted into total kinetic energy using an assumed luminous efficiency, the fraction of the object's energy emitted as visible light, and that efficiency is itself a modeled quantity carrying large uncertainty. Then, diameter is derived from mass using an assumed density. Every step multiplies the error bar. So a factor of 5 between two numbers in the same release is not evidence of a cover-up. It is evidence that at least one of them is a rough estimate published without its uncertainty attached. Anyone arguing concealment has to explain why an agency would publish two mutually inconsistent numbers in the same paragraph, on the same public web page, where anyone with a calculator could find them in 90 seconds. It is still worth noticing. And the published size and mass together imply a bulk density of roughly 2,200 kilograms per cubic meter, low for a stony meteoroid, and more consistent with a porous or carbon-bearing body than with a dense ordinary chondrite. Keep that in mind. It may matter later. Nobody detected this object before it entered the atmosphere. Not NASA, not the survey telescopes, not anybody. That is not a failure. It is arithmetic. A 16-inch object is roughly 0.41 meters across. The planetary defense surveys currently operating are calibrated to find objects 140 meters and larger, the size class that threatens a region rather than a rooftop. Kelly Fast of NASA's Planetary Defense Coordination Office told the American Association for the Advancement of Science in February of this year that only about 40% of that population has been cataloged, with roughly 15,000 objects at that size still undiscovered. This rock was roughly 340 times smaller than the floor those surveys were designed to reach. It was not merely undetected. With the instruments that currently exist, it was undetectable, right up until the moment it started glowing. That reframes the entire event. The question is not why nobody warned Washington State. The question is what fraction of objects in this size class arrive completely unannounced, and the answer is essentially all of them. This also disposes of the first claim that started circulating within hours, that the object was a satellite or spent rocket body re-entering and being described as a meteor. Orbital hardware comes down at roughly 7 to 8 kilometers per second because that is orbital velocity. This object was measured at 14.6, roughly double, and you cannot get there from Earth orbit. You can only get there on an orbit around the Sun. Re-entering hardware also behaves differently. It fragments into a long, slow train of separating pieces visible for tens of seconds and often more than a minute. This was one object, 4 seconds of flight, one fragmentation event, and a sonic boom. The kinematics are not close, so it was a rock. It came from beyond Earth orbit, and nobody was tracking it, which leaves the question in the title, and it has a more interesting answer than it should. An object traveling due north across the sky came from a radiant in the south. That is simple geometry, and it is the thread that leads somewhere. Start with the ground track. NASA published a start point above Soap Lake and an end point above Sims Corner. Those two coordinate pairs differ by 0.438 degrees of latitude and only 0.004 degrees of longitude. Work out the heading, and you get 0.35 degrees north within a fraction of a degree of true north. The entry angle comes to about 33.6 degrees from horizontal, a shallow to moderate approach rather than a steep plunge. Now calculate where the anti-Helian radiant was sitting above central Washington at that exact moment. The anti-Helian source is not a meteor shower. It is a broad, diffuse region of sky centered roughly opposite the Sun, near the plane of the solar system, and it is permanently active. The objects that appear to come from it travel on prograde, low-inclination orbits with sizes near 1 astronomical unit. Bodies going the same direction we are, in roughly our plane, which Earth encounters in the direction away from the Sun. At the moment of entry from that location, the anti-Helian radiant sat at an altitude of 28.2 degrees and an azimuth of 176.2 degrees. That is due south. An object radiating from that point travels north. Run the same calculation for the Perseid radiant, and you get altitude 39.7 degrees, azimuth 43.5 degrees. Northeast. A Perseid from that radiant would have traveled toward the southwest, in the exact opposite of what was observed. So 4 separate lines point the same way. Travel direction matches. Speed matches. 14.6 kilometers per second is squarely in the anti-Helian range and nowhere near shower speeds. Entry angle matches. And behavior matches. It survived down to 45 kilometers, deposited enough energy to produce sonic booms at ground level, and may have dropped stones. That is asteroidal behavior, and anti-Helian source bodies are asteroidal, which would be a mildly interesting technical footnote, except for what happened earlier this year. In March, the American Meteor Society published an analysis of the first quarter of 2026. They took all 67 fireballs from those 3 months for which a trajectory could be resolved, computed where in the sky each one came from, and compared the result against the baseline from 2021 through 2025. The tight anti-Helian zone produced 14 events. The expected number was 3.6. That is a 4.1 sigma excess. Under Poisson statistics, the standard way of modeling how often rare independent events should occur, that is roughly a 1 in 40,000 result, at a sky density double the previous maximum on record. And 22 of the 67 trajectory-resolved fireballs that quarter were tracking the anti-solar point on low-inclination prograde orbits with shallow entry angles, textbook anti-Helian geometry arriving at 3 to 4 times the normal rate. A second cluster was stranger still. 12 events came from radiance above 70 degrees declination, far northern sky, against an expected 2.4. That is 4.3 sigma, roughly 1 in 118,000, in a category where the previous single-year maximum was 5. Now the honest version, including the parts that weaken it. The radiant calculation for the August 14th object is a derivation, not a published solution. It comes from NASA's own start and end coordinates, but NASA did not publish a radiant. Solutions of this type typically carry radiant uncertainties of 10 to 20 degrees, and the anti-Helian source is broad and always on, which means a meaningful fraction of all sporadic fireballs on any given night are anti-Helian source. That is precisely why the first quarter excess had to be measured statistically rather than simply noticed. So a single event proves nothing. What it is a data point that lands in an interesting place. There is a wrinkle, and it is the reason this story is not closed. In July, a researcher at NASA's Meteoroid Environment Office named Althea Moorhead posted a paper with a memorable title, A Cornucopia of Null Results. She applied statistical regression to the American Meteor Society's fireball counts and found that the number of events reported in early 2026 was in line with the overall pattern of activity, with little evidence for the phenomenon people had been calling the February fireballs. That result is solid, and it does what it says. But read what it actually tests. It tests counts. How many fireballs were reported? It does not test radiance. Where in the sky they came from. Those are different questions, and a regression modeling growth in total reported events cannot explain why 22 out of 67 trajectory-resolved fireballs arrive from one narrow band of ecliptic sky. There is a further irony. The American Meteor Society had already conceded that its total counts were statistically overdispersed, and that under a negative binomial model, the excess came out at 1.8 sigma. Not significant. So the null result confirmed something nobody was seriously claiming, while the directional signal went untouched, along with two other physical facts from that quarter: sonic booms on 82.5% of large events, and 3 meteorite recoveries inside about 10 days against a worldwide baseline of roughly 10 per year. The honest position is this: the strongest surviving piece of the 2026 fireball anomaly is a direction. And on August 14th, something came out of approximately that direction, at approximately that speed, at approximately that entry angle over Washington State. That is not proof of anything. It is one more entry in a column nobody has explained. And before anyone runs too far with it, the claim that something is being deliberately sent at us gets the physics backwards. The anti-Helian source is the most ordinary orbital neighborhood in the inner solar system, exactly where you would expect prograde, low inclination, Earth-crossing rubble to come from under completely normal circumstances. The word doing all the work in that theory is unexplained, and unexplained does not mean directed. The most plausible explanation on the table is a stream of debris from a relatively recent asteroid breakup that Earth's orbit is currently passing through. That would be new science. It would also be entirely natural. There is a piece of this that could still be resolved, and it is sitting on the ground somewhere in eastern Washington right now. NASA's release stated that Doppler weather radar indicates some small meteorites may have reached the ground in the area. This is the same technique used in March after the Houston fireball, and it works better than it sounds. Falling meteorites show up on weather radar as a small non-meteorological echo drifting downward in the minutes after an airburst, and those returns can localize a strewn field to within a few kilometers. Lunsford, speaking before the formal solution was public, guessed fragments might come down near Bridgeport or Brewster. NASA's terminal point puts the fragmentation above Sims Corner. All of those locations sit in Douglas County, in the channeled scablands north of the Columbia River, open shrub steppe and dryland wheat country, as places to hunt for black rocks the size of a fist that is unusually good terrain. As of this recording, no recovery has been announced. That is worth stating clearly because these searches often produce nothing, and the absence of an announcement is not evidence that something is being withheld. For scale, this was a modest event. In March, the Ohio fireball involved an object of roughly 7 tons, about 2 meters across, releasing around 250 tons of TNT equivalent. Houston, 4 days later, was about 1 ton, breaking up 29 miles up, releasing 26 tons, and dropping a fragment through somebody's roof. Washington, on August 14th, was 170 pounds and 10 tons of energy, the smallest of the three by an order of magnitude, and it still lit 4 jurisdictions and rang 5 volcano stations. If fragments are recovered near Sims Corner, laboratory work would answer several of these questions at once. If the stones turn out to be ordinary chondrites, that is the most common outcome in the catalog, and the story ends as a well-documented but unremarkable fall. If they turn out to be achondrites, specifically the Howardite-Eucrit Diogenite family associated with the asteroid Vesta, that puts this object in the same group as 2 rare recoveries that landed 9 days apart in March. A suspected Diogenite from a daylight bolide over Europe on the 8th, and a confirmed Eucrit from the Ohio event on the 17th. 3 recoveries inside 10 days against a global baseline of about 10 a year was the hardest physical fact of the spring surge, and it has never been satisfactorily explained. Measuring the cosmic ray exposure age of a recovered stone would also tell us how long that fragment has been traveling as an independent body since it broke off whatever it broke off. That is as close as we can get to a real answer to the question in the title. So here's what to watch. Watch for a recovery announcement out of Douglas County over the next few weeks, and if one comes, watch for the classification that follows. Watch for whether anyone publishes a radiant analysis for the second half of this year that tests direction rather than counts, because that is the open question, and it is answerable with data that already exists. And watch the Cascade infrasound record, because those 5 stations just demonstrated that instruments built to listen for one hazard are quietly documenting another. We caught this one by accident, with instruments pointed at volcanoes, and we still cannot say where it came from. That is not a scandal. It is the current state of the aperture, and it is the reason the next one will also arrive without warning.